Good evening, students.
Good evening, sir.
Welcome you back for another important lecture on lanthanoids and actinoids. As I told you, this is an important topic and a lot of questions are expected from this topic in the coming papers. Let me give a recap, fast recap and few important concepts and questions which have been discussed, students. When I talked of lanthanoids, student, lanthanoids, what we have been, what we have told you, where the series begin from, you have 57 is lanthanum, yes or no?
Yes, sir.
58 is cerium,
Cerium
and then it goes up to
71.
71. What is the
Lutetium.
name of that? Lutetium.
Lutetium.
71. Students, so what we have information on, this belongs to, tell me which group number.
Group 3.
Question has been asked again. I'm telling you, what is the period number?
Period is 5. Period 6. Period 6. 6 and
Yes,
7. Yes.
yeah.
Period 6.
You don't try to hurry up the answer because a question is 1 mark and you will be losing 1 mark unnecessarily. You know it. Sixth period student. This is the sixth period. That means what you are saying is xenon is of what 54,
54.
and after that what was the lanthanum story? This you are saying is 6s2. Then how much you have one electron in the
5d1.
5d. This is how we learn the things. We are not remembering and we are not cramming the things. We are trying to learn them, student. Question wise answers are there. After this, you are saying then a series begins in which the electrons start entering from 4f1 to the 4f40.
F14.
That's what we say.
Yes, sir.
How many elements?
14.
Okay, 14 elements, students. You can keep on noting everything is very important. 14
Yes, sir.
elements from cerium, we are saying 4f1. You will go up to 4f14, students. Lutetium 71. Atomic number also I have to remember because electronic configuration will be asked in the paper. Then how will we write? Okay, so this and lanthanum is included in the series. These are 14 elements.
Yes, sir.
Okay, 14 elements. And why they are called lanthanoids? Why they are called lanthanoid, students? We learned it about that. Why they are called lanthanoids?
Because lanthanum is because the series begins from lanthanum, although lanthanum does not have an electron in the f orbital, but still its properties resembles those of the rest of the elements in the series.
But we are saying the properties of lanthanoids, the properties of the lanthanoids, student lanthanoids resemble with properties of properties of lanthanum.
Lanthanum.
Lanthanum. Therefore, they have been named even as lanthanoid. Okay, that also we understand. Everything should be clear. Then I said ki we discussed, student, the electronic configuration of these elements.
Yes, sir.
All right. So what you are saying, you this is what we call as a inner transition
Transition elements.
4f series. So you are saying you have 6s2 5d0 to 1 4f
4f 1 to 14.
14. This is the outermost valence shell. General electronic configuration of these elements, student. General electronic configuration. This we should know about it very clearly because questions are asked on the electronic configuration also. This is my outermost as sixth period. This is belonging to the next penultimate shell,
Penultimate shell.
and this is called anti-penultimate.
Anti-penultimate shell.
This is n minus 2 1. So I should write it like this: n minus 2 f 1 to
F1 to
14
14. N minus
n
1D.
minus 1 d 0 to
0 to
1
1.
and
And
n
NS2.
ns2. Okay, so I'm now getting for the actinide, ready for the actinides also, the 5F series also I can write on the same basis. Okay, all right. Then students, we have told you the oxidation states. Questions are asked on that, students. This is actually this F, as you can see that F4F orbital is not the outermost one.
Yes, sir.
4, 5, and 6. This is embedded. This is what we say that it is embedded, student, embedded inside the what 6 and 5D. So it is embedded inside the atom. And outermost are your D and S. The result will be it is not very well exposed to the surrounding.
Okay.
Not exposed to the surrounding means the other ligands or other ions which are going to come, they will interact more with these than with this. Not exposed to the surroundings. You can say that it is buried inside. What we say? It is buried inside. दबा हुआ है अंदर as compared to this. So the electrons are entering into the n minus 2 F. When I discussed the oxidation state, students, you have seen that most of the common, what is the common oxidation state, student?
Uh, Common oxidation states are uh, +2,
This plus 2 is not the correct answer for common oxidation state. But we have shown
+3. +3
for the
is the most common
Ln
oxidation state.
plus 3. So the oxidation state, what we have shown, Ln3 plus. Plus 3 is the common oxidation state, student. That means electron is being removed from the S first, then D, and then this. But certain elements also exhibit few will exhibit
+2 and +4
plus
also.
2 and plus 4, where this will be exhibited when you will have 4F0, 4F7 and 4F14. ठीक है, extra stable
Yes, sir.
configurations. These are extra stable configuration. You know about that, half filled or completely filled. There are
Yes, sir.
points to be noted because there are questions based on this, questions based on this. The oxidation state would be there if F0 is there and F7 is there, F14 is there. Okay, coming to the next part, student. All the things I'm talking are basically questions in the paper, students. Pay attention to what I am talking.
Yes, sir.
How the questions are put in the very small questions are given. Unless we understand, we will not be able to give correct answer. Further, we have discussed, students, their atomic and
Ionic sizes.
ionic radii. What was the important point about this? Tell me. What
Lanthanoid contraction.
before that? What I want to say, we are moving from cerium to lutetium.
Lutetium.
Cerium to lutetium, we are moving 58 to 71. What will happen to the size, student? Or if you are saying these are
Overall decrease.
Ln3 plus ions, their
Decrease in size.
atomic size decreases. Now the question is how big or how small is the decrease? How much is the decrease? It is large or small?
It is small.
Okay. Important point to note down, student. There is a decrease in radius, but there is a very small decrease in radius, students. Why there is a small decrease in the radius, student, as compared to other groups where you see large changes, here you see less. How do we answer these type of questions, students? You are saying with increase in size decreases with increase in atomic number, students. I can write it.
Yes, sir.
Okay, very important point. Atomic number increases, atomic size decreases, but small decrease in the radius with increase in students atomic number. Correct? If I write anything wrong, you will tell me, students.
Yes, sir.
Okay. Now, the nuclear charge is increasing with increase in atomic number. Yes or no?
Yes, sir.
With increase in atomic number. You are saying atomic number is increasing. Nuclear charge increases. What happens when electrons are entering into 4f subshell? ठीक है?
Okay.
And once as you start adding the 4f, what will happen? There is a screening
Screening effect.
effect. What will happen, students? Screening effect also works, nuclear attraction works. But screening effect will become more important as more and more electrons are added into the 4f subshell. But we, in general, we know the screening of F is less
Less than that of D.
than S and P. We already know that. But what will happen with addition of electrons? With addition of electrons, students, screening effect increases. What happens to screening effect increases? And screening do what? The repulsion between electrons push the electrons away from each other. Nuclear charge is pulling the electrons towards itself. So somewhere the result is the cumulative result. Cumulative means
Okay.
okay, put it like this. Cumulative. You can't hurry up anything because I have to think before I write. Students, I'm not going to go fast in anything because then some mistake could be there. I have to use my mind, pay attention. Cumulative means the addition of both these effects. Cumulative effect. There are two effects, nuclear attractive force and screening effect operating against each other. But we know the screening of F is not that good, The screening of F is poor as compared to S and P, that we already know. Okay? This screening is
Yes, sir.
less than S and P. So the effect is not that strong. The result is that there is the nuclear attractive force takes over the screening effect. There is a decrease in size, but decrease becomes less. That is why The size decreases by small value.
Okay.
By small value, students. Okay. And what will be the result of this student when their size is decreases small? For example, if I take cerium is around 165 picometer, and this is around 156 picometer. You can see that decrease is very small.
Yes, sir.
Other exact numbers can be seen in the book. I could be doing some. These numbers could be little here or there, but the decrease is only about 10 units from here to here, 9 or 10. So about 9 picometer change, which is very small as you are adding how many 14 elements. So almost sizes are quite similar.
Okay.
So that what will be the consequence of that, student? Everything has a consequence. What will be the result or consequence of this? They have
Same
almost
size.
have similar sizes,
Same size.
though there is only small decrease. Therefore, they will show similarities in their properties, students. So there will be close similarities in their chemical properties. And because occurrence also, it will be almost, they may occur together because they are of same size.
Okay.
And when the properties are similar, student, the separation becomes very difficult.
Difficult.
Separation is difficult. Okay, very important point. And I have told you that a special method is used. Ion exchange, ion exchange separation, ion exchange resin, which is used for the separation. We have told you where complexes are formed and then they are removed. Absorption takes place and then complexation takes place. That is not in our course in detail, so we are not talking, but we know about the story of that. So some idea
Okay.
is there that nucleus n equal to 1, if I say, then what happens? N equal to 2, 3, 4, 5, how much? 2, 3, 4, 5, 6, and this is my 7. How many? Sixth period, no? This is not required. This is not required. Sixth period. Or
Yes,
sixth
sir.
required, no? 1, 2, 3, 4, 5. This is my sixth. So here you have S. Which one is that? 6S2. And 5D will be here.
Yes, sir.
And 4F is inside that. This point. See, that is why I'm saying it is embedded, deeply buried. Has outermost are these ones. This
Okay.
is inside N minus 2, 4F. So the more electrons will be added, there will be more shielding to these electrons, more shielding. But otherwise, the shielding of F is not that strong as compared to S and P. That we already know because of the shapes of these orbital, students. They say diffuse and large in size. So their screening is poor as compared to P and S subshells. So students, what we will find these some of the properties which we are talking about. Okay. So we have oxidation number, oxidation states, ionic radii, electronic configuration, and further what we have told you, fifth point. Basically, these lanthanides, student, are silvery white soft metals, and they will tarnish. Now they are going to react rapidly in air. So they react with air. their hardness increases with increase in atomic number, students. As you can see, the sizes are decreasing
Yes, sir.
and melting points are also high. They have high melting points, maybe 1000 to 1200 Kelvin. They have metallic structures. If they ask you what are the properties of the lanthanide, students, and they are good conductors of heat and electricity. Metals, and important point is that
Magnetic properties,
they exhibit
color.
colored. Many trivalent lanthanides are colored. Colors of lanthanoids, students. Important question for the paper now. Many of these, trivalent M3 plus, which we represent by Ln3 plus ions. Many of these Ln3 plus are colored, students. What is the reason for the color of the question?
Okay.
Why lanthanide Ln3 plus are colored? They are colored some in the solid as well as in aqueous solution. In solid state and in aqueous solution, students. Okay, what is the answer coming now? The color is due to
Uh, uh, the
F,
half-filled f orbitals.
FF transition. Just as we talked of DD transition, here there will be a lower energy F subshell. Excitation of electron, student. Excitation of electrons from lower F subshell to higher, ठीक है, F subshell.
Yes, sir.
This is enough for us. We don't want to go into more details of this.
Okay.
That is what we call as FF transition. FF transition, students. So when electrons are present in the F subshell, there is can be color, student. Questions have been asked. Questions have been asked in this matter, the color. But what will happen, students? What will happen? The question was, okay, moving further. What I'm talking color of Ln3 plus ions. ठीक है? Question is, student, now the
Yes, sir.
question was given in the paper that uh, La3 plus, La3 plus, Lu3 plus, Lu3 plus, they are colorless. Why? Explain. Now they are colorless. How will we explain this, students, now? How do we answer if I have supposing cerium 4 plus? What is the catch for the students? I told you that answer first thing we find is the electronic configuration.
On a configuration. For lutetium, it will be 4F14,
Just
3
wait
plus
for a minute.
4F14.
Don't hurry up. We will go step by step. We never take 5 steps together. You are going for exam. What is the configuration of lanthanum student? 57?
Xenon 54,
54.
so 4F0, 5D1, 6S2.
4F0, 5D1,
5D1,
6S2.
6S2.
What will be lanthanum 3 plus?
Xenon 54,
This is F0,
4F0.
4F0. Okay. What is the configuration of Lu 3 plus?
Xenon 54, 4F14, 5D1, 6S2.
Wait. Slow. Don't go fast with me. You see that I'm very clear that there is nothing to hurry up. 4F.
4F14,
What is the atomic number? 71.
71.
4F14
Yes, sir.
and 5D
5D1,
and 6S2. Because I even
6S2.
electronic configuration is asked in the paper. But if I practice, then I am more comfortable. I will be able to do it in 30 seconds in the paper. What is this? Lu3 plus?
Xenon 54, 4F14.
4F14. Okay. Now I'm coming to cerium 4 plus.
Cerium 4 plus will be Xenon 54.
54. 54 xenon. Okay?
Yes, sir.
One thing you should know that what I have said. In the configuration of notation. Okay?
Yes, sir.
I have shown it here. So cerium 4 is 54. That is F0.
Yes, sir.
Can we give the answer of this now? What do you find? F0. There is
No electron in F orbital.
no electron. Here also. And what happens here? 4F14.
Fully filled F
No
orbital.
unpaired electron. Now I am coming to more important point.
Okay.
Therefore, students, I can say that color will be due to presence of unpaired electrons in the. If there are unpaired electrons, if there are, I am concluding another important thing which I will use in the paper, students. If there is no unpaired electron, students in 4F subshell, then that will become the metal or the metal ion will become colorless.
Okay.
Colorless. Okay? I can
Okay.
use this in the paper now. Is it okay?
Okay.
These are the questions for the paper, but you see, we don't cram the things. We know what we have to write. Okay, very important result, student. Very important result is coming. What we find, student, further in the book also he has written that La3 plus in the NCRT, Lu3 plus ion show no color. That means it can be a question in the paper. No, that is the situation. Okay? We have already answered that question. We know. But rest will show colors because if they have one or more unpaired electron in 4F student, they will show color. There is an absorption band. What is an absorption band, student? When electrons are excited from lower F to higher F higher energy of subshell, what will happen? They will absorb light, they will absorb, ठीक है, some wavelength, they will, what will they do? They will absorb, because of the excitation, what will happen, student? They will
Okay.
absorb, they will absorb energy or light, I'm saying, of a particular wavelength. That will, there will be absorption band, but in this 4F transitions, 4F transition, which I'm saying FF transition, what happen? Excitation from F to F, student. The absorption bands are narrow. The absorption bands are narrow, students, because the excitation is taking place within the F to F. Therefore, there is a narrow word has been used in the book. That's why I'm talking of it. Why will I otherwise speak of this? Question is coming from NCRT, and you don't know what is the meaning of a word which is using. The student don't know. They have used this word absorption band is narrow for, because the transition are FF, and you have seen FF is buried, embedded inside. It is not exposed, student. It is
Yes,
not
sir.
affected by the surrounding. We have shown you in the last thing. Where
Yes,
was
sir.
that? I have shown it. Seen that 4F is where? Here.
Yes, sir.
So what will happen? This is not exposed to the surrounding. Which are exposed to the surrounding are the outermost. So the result is that here the band is narrow, student. Band is narrow. They is mentioned in your book. So I have explained to it. And students will just ignore it. Question can be put on this. Whereas the band will be broader when I will talk of actinide, because there will be 5F orbital. There is a difference. This is more deeply buried inside that. Okay, the bands are, student, narrow in this case, because the shape of the 4F is different from the 5F. If we will read higher books, you know, it it has a node. It doesn't have a node. There is a node which we don't want to discuss at this point in this class, because that we will see in higher classes. So there is excitation of electron from F to F. The lanthanide ions, which will have F0 and F14, they may or they will not be colored. The condition we have told you, that there is excitation of electron and unpaired electrons should be present, then colors will be exhibited. Colors will be exhibited. Okay, further, student, further question was this: what about ytterbium? If I write ytterbium 2 plus, will it be colored, student?
Terbium 2 plus. Uh, Terbium 2 plus. Yes, sir. It will be colored.
What is the,
No, wait. It
what is
has
the first? I
40,
said,
60,
ki before I
90
answer, what is the electronic
electronic
configuration?
configuration.
How much is the,
No, it will not be colored because it does not have
what is the atomic number of ytterbium?
70.
See that certain elements now which are nearer to the middle or nearer to the end, they are important for papers, because there is something in them. Behavior is different. That is what they want to see. Then how many electrons are there in the 4F? Terbium, what is the configuration?
It will be 4F14 5D0 6S2.
5D0. 4F14 5D0 6S2. So if I will write terbium 2 plus, then it
6S2
will
will
be,
go
I may not write 54 in
54.
the paper. I know 4F14.
4F14
So this will be colorless.
colorless.
Question, this is the way the questions are put in the paper, students. All right. So next property, magnetic property, students. We have also told you in the transition elements, they exhibit magnetic properties. And what type of magnetic properties, students, we are interested basically. What type of magnetic properties we see, students, in these cases?
Paramagnetic.
Paramagnetism, student. Because there we calculated the magnetic moments by using the spin only moment. But here the magnetic properties are complicated because both the orbital and spin magnetic moments contribute. I'm not going into details of that. That is not required for us. Okay, I'm just telling
Yes,
you
sir.
the magnetic property here are will depend on the two things: spin. There is a spin magnetic moment
Yes, sir.
and orbital magnetic moment. Both will contribute. I mentioned it. But in the 3D transition element series, we said this is quenched. I told you there,
Yes, sir.
and only this was used. Here, it will the formula will not be same as n to n plus 2. Here they use J, which involves both the magnetic moment, spin and orbital angular moment, magnetic moment. But we don't have in our course, so we are not going into details of that. Okay, but we have mentioned to you. We calculate the value. Probably in the book you won't see the values of these magnetic moments. They have not shown any table of that. Have they shown? No. So I'm not going into it. If we have to calculate, we have to use some different formula. But
Okay.
paramagnetic depends on the presence of unpaired electrons. ठीक है?
Yes, sir.
If there will be unpaired electrons, students, if there will be unpaired electrons, then they will exhibit paramagnetism.
Paramagnetism.
Paramagnetism, student, this is important. Now the questions will be there on this. That if I take students, uh, for example, if I take Lu3 plus, ytterbium 2 plus. Question is, will they exhibit paramagnetism?
Lu3 plus and terbium 2 plus. No, sir. Both will not exhibit paramagnetism.
We have to again go back.
Write the electronic configuration, sir.
What is the electronic configuration of lutetium 3 plus
Lutetium 3 plus is Nn54 and 4f14.
or F14? Okay. And what is ytterbium 2 plus?
Terbium 2 plus is also 4f14.
So no unpaired electron.
Yes, sir.
No unpaired electron,
Electron.
students. Therefore, they do not exhibit paramagnetism, student. Paramagnetism, they don't show paramagnetism. So wherever such possibilities are there, students, we have to see others will show others which have unpaired electrons, other Ln3 plus ions which have unpaired electrons will exhibit
Paramagnetism.
paramagnetism, student. Paramagnetism. Important points have to be noted because there will be questions based on that. I'm trying to search the previous papers and seeing where the questions are coming, student, because this is an important chapter. Questions are going to be there, but what type of questions can be put is important, student. What type of uh, one more important thing is that, students, if the Ln or Ln ions, Ln3 plus ions or Ln plus ions, they have the same number of unpaired electrons. Same number of unpaired paired electrons, student, they will exhibit same color. Important point.
Okay.
They will exhibit same color, students. Color, students. For example, if I have something, uh, if I have, uh, if I have PR3 plus, PR3 plus, and what I have, PR, what else, and TM3 plus ion. I have two ions, student, PR3 plus and TM3 plus. Tell me how many unpaired electrons are present in each of them.
PR3 plus is
PR3 plus, what is the atomic number of this?
59.
And what is also TM is thulium, 69.
Okay.
What is the electronic config? First I will write the 59 PR. What is the electronic configuration? Xenon is 54, 6s2, 5d,
4F 4F13.
54 and 56, 56, 13. And what is 69 TM?
69
Really?
TM
How,
will be
what we are writing?
4F13.
Where is 13? How it is 13? Array 59 atomic number.
I'm saying, sir, for thulium it will be 4F13 6s2.
Okay, 4F13,
6s2.
5D0, 6S2. And for this,
For PR it would be uh, 4F3 5D0 6s2. 59. 4F 4F3.
how? 4F3, how is 4F3? 56, 57,
59. The atomic number is so
59, acha.
4F3.
4F3. PR configuration is 4F3. ठीक है?
Yes, sir.
4F3. So if I will form a 3 plus ion, what, how many electrons will be there? What will be PR3 plus?
PR3 plus will be 4F2.
4F2? 4F2.
2.
2 electrons.
And thulium 3 plus will be 4F12.
4F12.
Yes, sir. 2 from S and 1 from F will go.
4F12. Then how many unpaired electrons are there? 14 minus 13, 1. And here there are 2 electrons.
1, 2, 3, 4, 5, 6,
So
7, 8, 9, 10. 1, 2, 3.
the number of unpaired electron,
3.
how many?
For
1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. This is 2 electrons.
7 here gone.
That is PR3 plus.
5, 7, 8, 9, 10, 11, 12. 2 unpaired electrons in thulium.
7 means what? How many? This is 3 plus means. And what is the state of thulium? 3 plus. How many? 4F.
4F12.
If I write 12, what will be that? 1, 2, 3, 4, 5,
5,
6,
6, 7.
8,
Then 1,
9, 10, 11, 12. This
2
also has
unpaired electrons.
2 unpaired electrons. Oh,
Yes, sir.
they have the same number of unpaired electrons.
Okay.
Now both of them have the same color. It has
Same
been
color.
found they have the same color. Students, important point. They both are
Okay.
green in color. Aqueous solution, they are green in color. Students, you see the questions are put. If we know it, then it is easy. We have to see how we can work out the question, student. And this is a question, student, important question. This have been given somewhere. Similarly, students, similarly, what we find ND3 plus and ER is erbium 3 plus. They are both pink in color. Can you give the explanation, student?
ND3 plus and ER3 plus. Okay. It will be 2, 4F11 and NDS is 4F3. 3 electrons, 7 F. It will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 3 unpaired electrons. Sir, both have 3 unpaired electrons.
Both have 3. What is ND3 plus? What is ND3 plus, students? What is ND3 plus?
ND3 plus is 4F3.
ND3 plus is
4F3.
4F3. And what is ER3 plus?
ER3 plus is 4F11.
4F11. So, okay. How many hundred? 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3. And what about this? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So both have
Yes, sir.
3 unpaired electrons.
Electrons.
So colors will be same and they will exhibit paramagnetism. Unpaired electrons are there. Unpaired electrons are there. So we can say that we will see the similarity when you have Fn and F14 minus N equal. If they are equal, then they will exhibit. I don't
Same
have
color.
to work it out. I don't have to work it out, student. I can conclude. What is the conclusion? When they have Fn electrons and F14 minus N is equal, then they will have the same color.
Same color.
Okay, same color. All right. Okay, if I discuss their ionization enthalpies, students, you are going from, you are saying Ln to Ln plus, then you are going to Ln plus 2, Ln, what is this? First ionization enthalpy, second And you have third ionization.
Enthalpy. Okay.
The first ionization are around 600 kilojoules per mole. They are always given in kilojoules per mole around. Second is around 1200 kilojoules per mole. They are comparable with calcium.
Okay.
Comparable first and second. Comparable with calcium ion student compare with Ca. Therefore, they may in +2 oxidation state they may show behavior similar to Ca calcium in plus 2 I'm saying. And when it comes to third, you see what happens is that there is an exchange which take place in the d block elements. D block elements also we found there is exchange consideration when we removed electrons from the s orbitals. What happened? Exchange takes place. Of some irregularities were there.
Yes, sir.
And important point is that when you will remove third electron, if you have configuration students which are F0, F7 and F14, ठीक है?
Yes, sir.
If such configurations are going to be formed after removal of third electron, after you remove third electron, then it will be easier because these are stable configurations.
Yes, sir.
In such cases, what will happen? Value of there will be low value of student third ionization enthalpy. ठीक है? There will be low
Yes, sir.
value of third ionization enthalpy. So question. Ion, I'm saying IE3, that means third ionization enthalpy of lanthanum, gadolinium, and lutetium are abnormally low. Explain. Abnormally low. Explain, student. Okay, give me the explanation now. How will you explain, students?
Uh,
Write the electronic configuration before you answer any question. Student, again and again, I repeatedly gave you one important catch everywhere. 3D series also I said learn the electronic configuration. Here also I am saying you want to answer question in competition or anywhere. Go to the electronic
yes,
configuration
sir.
first. In 3D I told you which are stable, half filled, completely filled, or even T2G3
Full.
was stable.
Empty.
T2G3 was
Yes,
stable.
sir.
So these they were the concept,
Okay.
the question student. Those
Sir, they have empty, half filled, and completely filled f orbitals.
so when they will form Ln3 plus is what? 4F. Ln3 plus is what?
4f0.
4F0. Okay. And what is gadolinium 3 plus?
4f7.
What is lutetium 3 plus?
4f14.
So this is our answer in the paper. So they have stable students. They have stable, empty,
Half filled and fully filled.
half filled, and completely filled. Completely filled orbitals in F subshell. This is how we write answers in the paper, students. See, we have to
Okay.
write only one word, one line answer in the paper. We can't write anything we want. Exact answers are required because the key is given to the examiner who checks the paper. With words are written, lines are written. That's all. There is not a very paragraphs are not written anywhere. So I hope you are getting a feeling of what I am doing. The main thing is you should feel the subject.
Yes, sir.
You should learn it, student. You're not cramming anything. And learning requires a lot of practice also to be able to write their electronic configuration, which are difficult first time. Second time they are little easier. Third times they become little bit more easier. And then slowly and slowly by practice, students, we are becoming more and more used to and familiar with them. And that is what I say to the students. Those who are not writing, who are not practicing, they will go to nothing. This needs attention. This needs work. And why do I write so much? As you can see, I'm trying to write everything. I'm not just talking because I also learn when I write. I will also forget if I don't write. Okay, then this is the end of the first part of it. We have been telling you about the important characteristics of the lanthanide students, and we will continue more about this. And
Yes, sir.
actinides is our last topic in this. Mostly, I will tell you what type of compounds they will form and their reactions and actinide series. A question will be definitely coming from this topic. Very important.
Okay.
Okay, then we'll meet you in the next weeks.
Okay, sir. Okay, thank you, sir.
Okay, good night. We'll meet you next time.
Okay, thank you, sir.